Okay, students, continuing from where we left off. Now we know the three equations of motion. That is, V is equal to U plus AT, S is equal to UT plus half AT square, and V square minus U square equal to 2AS. Next, let's discuss the next equation. There is a fourth equation of motion. The derivation is not important. Therefore, I'm not going for the derivation. I'm going to discuss the fourth equation of motion, and we will understand a situation where we could use the fourth equation of motion. The fourth equation of motion is displacement at the nth second is equal to u plus a by 2 into 2n minus 1. Displacement at the nth second is equal to u plus a by 2 into 2n minus 1. That means you can find out the displacement at a particular second. If a substance is moving with a constant acceleration, the displacement at the first second won't be equal to displacement at the second second. That won't be equal to displacement at the third second. That is, if you want to find out the displacement at the nth second at any particular second, you could obtain it by using the formula u plus a by 2 into 2n minus 1. Let's try to understand this formula with the help of a problem. That is, in this case also we are taking a freely falling situation. The substance that we are considering is falling freely from a sufficient height. It's falling from a very large height. Then if it is freely falling means you could understand u is 0. Find out the displacement at the third second and total displacement in 3 seconds. This is our question. They are asking you to find out the displacement at the third second and the total displacement in 3 seconds. Let's find out the displacement at the third second initially. In order to find out the displacement at the third second, you will have to use this particular formula. Therefore, let me write displacement at the third second. It should be u plus a by 2 into, since it is third second, we are substituting instead of n 3. And you have to substitute instead of this n also 3, that is 2 into 3 minus 1. Displacement at the nth second, if it is u plus a by 2 into 2n minus 1, then displacement at the third second, it should be u plus a by 2 into 2 into 3 minus 1. That is, displacement at the third second is, what is u? In the case of a freely falling substance, u is 0. Therefore, 0 plus freely falling substance acceleration is acceleration due to gravity. For a freely falling substance, acceleration is acceleration due to gravity. Therefore, g by 2 into 2 3s are 6 minus 1. That is, displacement at the third second is equal to g by 2. Let me write it as 10 by 2 into 6 minus 1 is 5. Therefore, 5 into 5, that is 25 meters. 25 meters the displacement at the third second. Displacement at the third second. Okay. Then let's try to find out the total displacement in 3 seconds. In order to find out the total displacement in 3 seconds, then you have to use the second equation of motion. The second equation of motion is saying S is equal to ut plus half at square. Therefore, in order to find out the total displacement in 3 seconds, then it is S is equal to ut plus half at square. This is the formula that we have to use. Therefore, total displacement S is equal to, what is u? U is initial velocity, it is 0. Therefore, 0 plus half, let me write gt square. Or you could use that situation directly over here. Let me write S is equal to half g. G can be taken as 10 into t square. It is 3 square. 3 square. Let me write 3 square. Then 5. 10 by 2 is 5. 5. 9 5s are, yes, it is 45 meters. Therefore, the total displacement is 45 meters. That is, let us visualize that situation. If we are having a substance which is dropping means at initial time the substance is over here. Then after 3 seconds, that is after t is equal to 3 seconds, the substance will have moved a total displacement of what? 45 meter. This displacement will be 45 meter, in which from t is equal to 2 to t is equal to 3, that is at the third second it has moved a distance of 25 meter. At the third second it has moved to a distance of 25 meter means at the 0th second it is at origin, that is initial point. At t is equal to 1 second it should have moved a particular distance. At t is equal to 1 to 2 second it should have moved another distance, and at the time interval of t is equal to 2 to 3 second, that is the displacement at the third second. And in this case the displacement at the third second it is 25 meter. 25 meter. Let's find out the displacement at the second second. If you are finding out the displacement at the second second, it should be 0 plus, that is u0. Therefore, 0 plus a by 2 is 10 by 2 into 2n minus 1. It is 2 into n, that is 2 into 2, that is 4. 4 minus 1. That is, it will be obtained as 10 by 2 is 5. 4 minus 1 is 3. 4 3s are, no, 5 3s are 15. Then at the second second it has moved a distance of 15 meter. That means from t is equal to 1 to t is equal to 2 second it has moved a distance of 15 meter. Then let's find out the displacement at the first second. If it is displacement at the first second, then you could say it is 0 plus 10 by 2 into 2 into 1 minus 1. 2 into 1 minus 1, it is what? 2 minus 1, that is 1. Okay. Then it is what? 5. 10 by 2 is 5 meter. Therefore, from 0 time to 1 second, it is 5 meter. Then you could understand the motion. The motion of the substances. At the first second it has travelled 5 meter. At the second second it has travelled 15 meter. At the third second it has travelled 25 meter. Therefore, total is 5 plus 15 plus 25. That is 20 plus 25. That is 45 meter. Okay. Hope you have understood this. Then you could note one more pattern, that is, what is the displacement at the first second? Displacement at the first second, it was, let me write, it was g by 2. G by 2, 1 into g by 2, that is 10 can be replaced as g, therefore 1 into g by 2, that's g by 2. Displacement at the second second, it was actually what? 10 by 2 into 4 minus 1, that is 4 minus 1 is actually 3. 10 by 2 is g by 2. 10 by 2 is g by 2. Therefore, let me write it is g by 2 into what? 3. Displacement at the third second, if we are writing like this, in order to create a pattern, displacement at the third second, it was, look over here, 6 minus 1 is 5 and 5g by 2. Okay, therefore I could write it is 5 or g by 2 into 5. At the first second it was g by 2. G by 2. At the second second it was g by 2 into 3. At the second it was g by 2 into 5. Then can you say what should be the displacement at the fourth second? Fourth second, it should be g by 2 into, this is g by 2 into 1, it is g by 2 into 3, this is g by 2 into 5, then it should be g by 2 into 7. You could calculate it and it should be obtained like this also. Then what we can say from this is we could form a pattern that is displacement at the first second is to displacement at the second is to displacement at the third second is to displacement at the fourth second. It should be equal to, if you are taking g by 2 in all and if you are cancelling that g by 2, you could say it is like 1 is to 3 is to 5 is to 7 is to etc. Okay, therefore the ratio of displacement at the first second to the second to the third second to the fourth second is like the odd multiple, that is it is like 1 is to 3 is to 5 is to 7. Okay, or you could look at this situation also. Displacement at the first second was 5, means displacement at the second was 3 into 5. Displacement at the next second was 5 into 5, like this. Okay, therefore there is a pattern that you can obtain like this also. This is regarding displacement at the nth second. Hope you have understood this displacement at the nth second situation. We are stopping this video over here.